Alright, hi everyone, welcome to my Python crash course for Blender. I've been receiving too many requests to make Python videos, so I figured now's probably a good time to do it. So here we are. And naturally this is going to be a bit more of like a workshop format rather than a regular tutorial, so this will definitely be a longer video. If you're not happy with that, then that's okay, you don't need to watch this. But if you are interested in starting to make add-ons for Blender, then this is the video for you. By the end of this video, you'll be able to make this cool, strange, generative, emissive type effect thing. There's no real purpose behind this tool, but I think it's a good demonstration because it will show you how to access objects, materials, modifier stack, nodes, and all stuff like that. So before you get into it, there's a few things that you should keep in mind when using Python in Blender. First of all, you want to make sure that you enable the Python tooltips, and I'll explain what this is. If you go to Edit, then Preferences, under Interface, in here you'll see Python tooltips. And you should also have tooltips enabled, but if you hover over this, it will say what it is. It shows Python references in tooltips. Now, tooltips are where, say if I create an object and add a modifier, if you have a value in the interface and you hover over it, a tooltip will appear. And it basically gives you a description of what the value does. But if you enable the Python tooltips, there will be a dark gray description underneath that basically tells you the code path to that value. And this code path is basically an address inside of Blender that tells you exactly where to go when writing Python code or regular Python commands to access that value and change it. So this is super important because you probably aren't going to remember all of the names of these values in Python off by heart. So just by hovering over the value, you can remind yourself. Another super useful thing as well is that we can also open up a new window and go to Info. And basically everything you do in the Blender scene has a command associated with it. And in the info window, you can see exactly what this command is. So this is helpful, say, if you want to automate a specific workflow of yours, and there's a set number of actions that you do repeatedly, and it's something you want to automate. You can just do all those actions, then read back through the info window and see exactly what those commands were. You could then copy them and paste them and then use them. And at the moment, my Blender might look quite different to yours because I'm using a darker theme. It's a custom theme of mine. And also I've changed the startup file, so I've got my own set of pre-made workspaces up here. We're inside of the scripting one, which has the text editor window, as well as the Python console. So what I'm going to do is I'm going to press New in the text editor window, and this creates a new text object in the Blender file. Now I'm going to name this demos.py. And the reason I'm calling it .py is because all Python files end in .py. Well, actually, there's an exception that can be made there. Regular Python files end in .py, but there are some other extensions that we don't need to worry about. Also, if we go to View, we want to make sure that syntax highlighting is enabled. This ensures that when we write code, it will be colored appropriately, which will make it much easier to read. Okay, now we can actually get started. So if you haven't done any coding or programming before, then I highly recommend you watch my intro to coding video because it outlines some pretty commonplace principles and concepts that are relevant to every single programming language. These are things like abstraction, functions, variables, and data being represented by an address format and stuff like that. I won't explain all of those things here, so I recommend you go and watch that and then come back because you'll be in a much better position. One thing you'll need to keep in mind is that in Python, most of the code you'll be writing comes from modules, otherwise known as libraries in some languages. A language like Python is usually prepackaged with a bunch of modules or libraries that serve different purposes. And when you run a Python script, it doesn't import all of them by default. And that's because it would be very inefficient, because there might be some libraries for networking, for text editing, for mathematics, as well as a whole host of other fundamental functionality. And then there's a huge library of community-made modules available online as well, which you can easily download. Now, when it comes to telling Python what kind of modules we want to use, we use the import command. And this basically says to Python, hey, we want to make use of any of the commands that are available in this module. So with Blender, the main module we want to import is called BPY for Blender Python. And if we look down inside of the Python console here, you can see that it says built-in modules and convenience imports. The built-in modules are BPY, BPY.data, BPY.ops, and props and types and context. And just to explain these in a bit more detail, BPY is basically basic Blender functionality. BPY.data is what we use to modify the contents of a file and search for it. So all the things like object and mesh data, textures, and stuff like that. BPY.ops is for useful operations, say creating new objects or materials and stuff like that. And props and types is stuff that we won't necessarily get into. We might take a look at props a little bit later on, but this is slightly more advanced stuff. But here's the thing, when you write a Python file inside of the text editor, it does not automatically import these modules. So we need to manually write import BPY, whereas in the console, we don't need to do this. So just to demonstrate this, if I create a basic object like a cube, in the console, I can type in bpy.context, which contains all of the contextual information for the scene, .active_object. Then it's going to say bpy.data.objects_cube. So it's basically giving us an address for the selected object. So we know this works. However, if I did not import bpy and I typed the same thing, then when we go to run this, we immediately get an error. And it's because bpy has not been imported. So this is something very important that you need to keep in mind, that if you run Python code in one part of Blender, it will not necessarily run the same as another part of Blender. Now if I go import bpy here, and then press Alt-P, we can see that it runs the script and no error appeared. Another thing to keep in mind as well is that if you run stuff in the text editor that should output things to a console, it won't output it to the Python console here. Instead, any errors or messages that are created by the text editor will go into the system console, which you can get to from Window and toggle system console. And we can see here where we had a BPY error, BPY not being defined, the last time we ran the script. So now we've got the boring important stuff out of the way, let's take a look at actually how to make stuff. So starting from an empty scene, one way that you can add new objects to Blender is to make use of the bpy.ops module. So ops, as I said, is basically a collection of really useful commands. Generally, if you're doing complex code, it's best to avoid ops as much as possible. But if you're doing lightweight, workflow improving scripts, then they're quite useful and they can save you a lot of extra lines. Now these code paths work like an address, as in a web address or a folder address, but instead of forward slashes or backslashes, we're using dots. We can filter down through categories. So bpy.ops.mesh means that we're now taking a look at the operations that are related to meshes. And then we can type in primitive_cube_add. So what this command will do is add a primitive cube. So if I run the script, which we can either do by going to text, run script, or pressing Alt-P, or pressing this button over here for run script. Alt-P is the easiest way to do it. Then it will make a cube. So we've imported bpy, and then we've called the operation to add a cube. Very simple, 2 lines of code. But now that we've created the cube, we don't really have a way to modify it in any way. What if we wanted to change some of the values like the rotation, the scale, the position, or add modifiers to it or stuff like that? We basically just blindly created it and we don't have a reference to it in any way. One thing to keep in mind is that when we call operations like this, Blender automatically makes the cube the newly selected object. So we can actually take advantage of that. I like to store it inside of a variable called SO, which stands for selected object, but you can call it anything you like. So I could write here SO equals bpy.context.active_object. So now after we've created the cube, we've now stored it inside of SO, which makes it easy to manipulate, because then we can just go SO dot and then modify any data that we can find. So let's give this a try. If I type in SO.location and then square brackets, and inside there put 0, and then I'm going to do something like 5. Now let me just explain this. Some variables are single values, and some variables are more complex, like lists or arrays of objects. And basically they can contain more than one value. With an array, all values start at a position of 0. So 0, 1, 2, 3, and then they can all be equivalent to different things. In the case of this location value, 0 equals x, 1 equals y, and 2 equals z, x, y, z, regular Cartesian coordinates. So by typing in so.location 0 equals 5, what we're saying is we want the x position of this cube to be equivalent to 5 units. So if I press Alt-P to run this, and we zoom out, we can see that we've created a cube and it's moved 5 units on the x-axis. So that's a simple way of how you can move objects. But what about rotation? Now rotation is slightly more tricky because you can't just pass a regular number to it. Instead we have to work with radians. Typically when you describe rotations, you're either using degrees or radians. Degrees are something that's easier for us to understand, but not so much for a computer. So if we have a degree in mind, like 45, 90, 180 degrees that we want to rotate an object by, we need to convert that degree into radians first. But there's an easy way to do this, an easy way and a slightly harder way. So I'm going to start with the harder way, and then I'm going to show you the easy way, and then you'll see how useful that is. So let's say I wanted to move this cube by 45 degrees. So if I type in degrees equals 45, just so we know, then I'm going to create a new variable called rad for our radians. Now, how do I convert degrees into radians? The equation for this is degrees multiplied by pi divided by 180. Now, I promise we won't get too mathematical for the rest of this video, but this is something that's quite important just to know. The asterisk or star symbol in code means multiply, and the / means divide. So rad will become the radian value of 45. Now, I can prove this to you by going down into the Python console here. So if I type out this again, degrees equals 45, rad equals degrees multiplied by pi divided by 180, and then type rad, it gives us 0.785, blah, 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 blah. But there's a special function we can use that's a lot easier to understand to convert these degrees for us. Radians, and then in brackets, 45. And you see it has the exact same value. Now here's the thing, we could type in radians 45 into this code, but this wouldn't work, and I can prove this to you now. Error message. The reason is because radians comes from a module that we haven't imported yet. See, radians does not come from BPY, it actually comes from one called math. Now with Python, you don't have to import entire modules, you can just import the individual elements of the modules that you want. So I'm going to type in from math import radians. And this will basically import the radians command into our script for us to use. So if I delete this, and of course we haven't actually told the object to move, so if I run this now, it's not going to do anything, but it won't give us an error because we have the command. So I'll delete that again. And now let's actually put this to use. so.rotation underscore Euler. Yes, that's not just rotation, it's rotation underscore Euler. Euler representing Euler angles. You don't need to know too much about that, just trust me. And then in brackets 0, because we're working with x rather than y or z, plus equals radians 45. And now let me get rid of that original line. Now what does plus equals mean? Basically plus equals is a way of writing out so.rotation underscore Euler 0 equals so.rotation underscore Euler 0 plus radians 45. So what we're saying here is the x value for the rotation should be made to be the x value plus the radian value. Now obviously this is quite long to write out, so plus equals is just a way of saying, hey, just make this equal to the value of both of them combined. So now if I run this, we see it creates the object, moves it 5 units on the x-axis, and then rotates it by 45 degrees. Okay, now I'm going to remove this move code because I actually just want to keep the object centered, but now we're going to move on to taking a look at how to add modifiers. So, how do we add modifiers? We're going to step away from this script for a minute so I can demonstrate this using the console. I'm going to manually create a cube. Then in the Python console, I'm going to type in so equals bpy.context.activeObject again. So we're basically storing this cube inside of so. What I can type in now is so dot. Now this is actually a good point for me to talk about the auto-completion feature in the Python console. If you type in a value and then dot, as if you're looking for the next part of the code address, and then press tab, it will basically give you a list of all the possibilities of things you can type next. So in here we can see that modifiers is a valid thing that we could type next. So so.modifiers, and then I can press dot and then tab for autocomplete again. And then we can see that there's a command here called new. So so.modifiers.new. We know that we're along the right lines for adding a new modifier to the cube. Now I already know exactly what to type, so I'm going to put brackets here now. And there's 2 values that the command can take. 2 string values. The first one is just the name that we're going to give to the modifier. It can be anything you want it to be, so I'm going to call it my modifier. But the second one is the type of modifier. This code needs to be absolutely perfect. So usually it's the uppercase shorthand name of the modifier. So for example, a subdivision surface modifier is subsurf. This tells Blender exactly what we want it to be. So if I press enter, we see that it's come back with a good value. It's now told us exactly how to find this modifier, bpy.data.objects cube.modifiers my modifier, but nothing has changed yet until we rotate the camera. As soon as we move the camera, it updates the scene. And if we look in the modifier tab, then we can see it here. So this is code to add the modifier. So I can write this in here as well. so.modifiers.new my modifier subsurf. But the problem is, again, just like before, we're blindly creating this and we don't have a way to modify the values of the modifier. So say we wanted to change the viewport number of subdivisions, how can we do this in the Python code? Well, there are two main ways to access the modifier values. Again, I'll show you the long-winded way and then I'll show you the easier way. So we could go so.modifiers square brackets my modifier and then access the value through here. So we can see that it's bpy.data.modifiers my modifier.levels. So .levels is what we need to type. And then I can change it to something like 3. And then I can actually test this down here in the console. Equals 3. And then we can see that immediately it increases the number of subdivisions. So that's fine. This method is what we would call the searching method, because we're going to the modifiers list, and then we're searching for my modifier, and then we're modifying the value there. But let's say you wanted to change lots of values on a modifier, one after the other, then it would be quite inefficient searching for the modifier for every single value that you wanted to change. So instead, what we can do is type in something like mod_subsurf. I'm basically creating a variable equals so.modifiers.new my modifier subsurf. So we're storing the newly created subdivision surface modifier inside of the variable mod_subsurf. So then I can do this, get rid of all this code, type in mod_subsurf, and it will do the same thing. So if I run this script now, it creates the cube, rotates it 45 degrees, adds a subsurf modifier, and then it increases the viewport levels to 3. Okay, but taking a look at this smoothed cube, I don't like the way that it's flat shaded, you know? So if I open up the info window here, let's say I wanted to apply the smooth shading to this object using Python, how would I do that? If I don't already know what the code is, I would either have to look it up or try to do some convoluted searching through the Python console. But no, like I said, with the info window, we can see exactly what commands are being called in Blender. So if I right click and choose shade smooth, we can see that the command being called is bpy.obs.object.shadesmooth. So this will apply the smooth shading to any object that's actively selected. And as we know, when bpy.obs creates an object, it makes this object the selected object. So I could just type in here bpy.obs.object.shade_smooth. So if I delete this, then run the script, there we go, it automatically creates it again and shades it smooth. So this is an example of how we can use the info window to inform our script. But for the sake of learning, I'm actually going to show you a slightly more convoluted way to do this. And by that, what I mean is we're going to create a loop and look at each of the individual polygons and then set them to smooth shading individually. So what I'm going to do is comment out the line of code we've written there. And I haven't mentioned it already, but the comments you can make by typing in the hashtag. And the colors will be different on your screen because I'm using a custom theme. But what it basically means is that Python will ignore everything on that line. So if I type in mesh equals so.data, now we don't need to create mesh, but it's just going to make it a bit easier to understand when we write the loop. So I can type in for face in mesh.polygons face.use_smooth equals true. So what this loop is saying is for every face that we find in the list that is mesh.polygons, otherwise known as so.data.polygons, we could just put that in here as well and that would work perfectly fine. Face that we're looking at .useSmooth equals true. So for every face we find in the polygons list, make it smooth. So if I run this, it does the same thing, makes all the polygons smooth. Now you'll notice here that some code has been indented. What I mean is that there's a tab. When we create loops or a new kind of scope, you always need to indent to a new line. So say, for example, that I did an if statement of any kind, I would then need to indent all of this. Say that I had another kind of for loop here, I would also need to indent this code. So basically it's easy to read and it's easy for Python to understand what code needs to run inside of what conditions. But we don't need to worry too much about that at the moment. I'm just going to reset this and bring back that line of code. So now when we run this, we've got a subdivided cube. Let's do something a bit more interesting with it. We're going to add a displacement modifier. So let me just make a note. Using what we've learned before, I can do mod_displace equals so.modifiers.new, my displacement. And then in here, I'm going to type in displace in capitals. So this will create a new displacement modifier. So let's delete this object, run the script, and we'll see it's a bit wider than before because that's what a displacement does to start with, and we can adjust the value. But the real power of displacement comes from created, generated textures. So now you can see why I've chosen to use the displace modifier, because we're about to learn how to create these textures programmatically. So just to take a look quickly, if I create a new texture manually and then go into the texture properties, we can see that all of the properties of the texture are very dependent on the type of texture that it is. So there's Voronoi, Musgrave, Magic, Blend, Image or Movie, Distorted Noise, etc. As we change the type, the settings also change. So first of all, we need to find a way to create a texture in the code, and then we need to find a way to set the texture type. This is actually quite simple. So if I remove this object, I'm going to type in, first of all, comment, new_text equals BPY, because we're not actually creating this data for the object, we're creating it for the actual Blender file. So this texture could be used anywhere else in the scene. .data, because we're modifying the data of the blend file. .textures. .new. So just like modifiers.new, we have textures.new. Inside of here, I can type in my texture. And again, here we can type in an uppercase ID for the type of texture we want. So just for demonstration, I'm going to type in distorted noise. And if you want to learn what each of the possibilities for these codes are, then they are available on the Blender wiki. And actually, just for reference, I'm going to copy the addresses in here, just so we have them visually on record. This is the place where you can find all the different codes. And I've just noticed I've made a mistake by typing text instead of text, so I can remove that T. So basically this will create a new distorted noise texture inside of the blend file. So say if I wanted to modify a value of that texture, I could write something like new_text.noise scale equals 2.0. And then if I wanted to apply the texture to our new displacement modifier, I would write quite simply this, mod_displace.texture equals new_text. And that would be it. So if I run this code now, it creates our cube, then subdivides it, rotates it a bit, then adds a displacement modifier, then creates a distorted noise texture, then applies the texture, but also modifies the noise scale. So for example, if I come in here, the size value is the noise scale value. So I can go in and modify afterwards, but now you can see how we can set the value inside of the Python code. Okay, that's all well and good. So now we know how to create an object, move its location, move its rotation, add a modifier, change the modifier values, shade it smooth, create textures, assign the textures to modifiers. How do we create materials for material nodes? Well, this is where things require quite a few more lines to get done. So I'm actually going to go to the shader editor window and to object, because we'll need to have a visual demonstration of this. So the first line is quite easy to understand because we've already covered most of this. New_mat equals bpy.data.materials.new. Just like our bpy data textures new, we're doing bpy data materials new because we're creating a new material object for the blend file. And then in here, I'm going to type in name equals my material. Now, why am I typing name equals into here? Because before we've always just typed in the value by itself. Well, for a lot of functions, there are different arguments that you can provide. And if you want to be very specific with Python and tell them exactly what argument you want to be writing for, then you can actually just type in the variable name equals this. So I'm just showing you a different way that you can do things. But now that we've created a new material for the blend file, we need to actually assign it to our object. So to do this, I can type in so.data.materials. So what we're doing here is taking a look at our selected object, the data of our selected object, the materials list for our object, of which there are currently nothing, and then .append. What append means is it's going to add whatever we provide to it as an argument to the list of materials. So we're going to go to materials, append, and then of course in here, new_mat, because we want to add our new material to our list of materials for the object. Now, of course, just to demonstrate something, if I create a new material manually, we have the option to either use nodes or not use nodes. And if we use nodes, we can always just easily change the surface shader here to something else. We're not going to worry too much about this. Instead, we're manually going to create a node and then manually going to form connections between the node we create and the material output node. And we're going to do this because I can show you how to access the different ports of a node and connect them together. So first of all, we want to tell the object that we are actually going to be using nodes. So I'm going to type in new_mat.use_nodes equals true. Now, to save us from having to write out a lot of code, I'm going to type in nodes equals new_mat.node_tree.nodes. Now, the reason I'm doing this is because I want to make this shortcut variable. Just like when we did the loop with the smoothing before, you can basically write a variable that acts as a shortcut between a longer line of code. So nodes is equivalent to writing new mat.nodetree.nodes. So now we'll have access to the node tree that we're creating for our new material. I want to create a reference to the material output node, first of all. So I'm going to type material_output equals nodes.get. Basically, this is a function for searching for a node. And then by using a string, I'm going to type in material output. So this is basically going to find the material output node and store it inside of our material output variable. Now, for this demonstration, I'm going to create an emissive shader for us because the emissive shader is my favorite type of shader, so let's use it. Node_emission equals nodes.new. So instead of using get to find a node, we're going to use new to create a node. And then here we're going to write type equals, and then I'm going to create a string, shader node emission. Again, there's a very specific code that needs to be written for the type of shader. And yes, I get it's a bit confusing. This is written with upper and lower cases, whereas the other types here are written in completely uppercase. These are just some things you'll need to remember. And again, there'll be a list of all the different types of codes you can write somewhere as well. Okay, so now we've got references to our two different types of nodes. We've got the material output node and the emission node. But now we need to find a way to connect these in code. So this is where we need to think about arrays again. Remember how I said that arrays are represented in square brackets and they start at a value of 0, and it's basically a list. So the first object in the list will be 0, then the next will be 1, 2, 3, etc. Think about the inputs and outputs of a shader node. On the left side here we have our inputs, and they're all in a line. This is an array of values. So taking a look at the principal BSDF shader, the first value, base color, would be at position 0 for the input. 0, 1, 2, 3, 4, 5, and going down, and so on. This BSDF shader output would be at position 0 for the outputs. So keeping this in mind, I now know how to manipulate the different inputs and outputs. So before we connect these, I'm actually going to make a slight change because one of my favorite colors is cyan. I'm going to set the color of the emission node to cyan. So if I type in node_emission.inputs 0, and I should actually create an emission node here just so we can see exactly what we're looking at. Input 0 is a color value. And I can change this to cyan here, but of course this isn't doing it in code. But if I take the RGB values and type in 0, 0.3, and 1.0, then this creates a cyan color, and I know this off by heart. So I can type in here .default value equals, and then I need to do this in brackets, 0.0, 0.3, 1.0, and 1. The final one is the alpha value. So this will basically set the color value of the emission node to cyan. And also, because I want to make it stronger, I can type in node_emission.inputs 1.default value equals, and I can do 500 for strength. So this is how we modify the values of a node. But now, say I wanted to connect these two together, how do I do that? First of all, I'm going to make another shortcut variable. So links equals mat.node_tree.links. So we're taking the list of all of the different connections between nodes and storing it inside of links. This will make it easy to add to. And then I'm going to create a new link equals links.new. And then in these brackets, this is where we're going to make the connection. This is quite easy to understand actually, because now that we know exactly where the addresses for our inputs and outputs are in terms of arrays, we can just type them in here. So node_emission.outputs 0, comma, material output.inputs 0. So to take a look at this visually, node emission, which is our emission shader, dot outputs, so the right side, position 0, which is this emission thing, and material output, this node, dot inputs, left side, position 0, surface. So it's going to make a link between these two, like that. So if I delete this object, run the script, okay, we'll see Python script failed. Now this is a good demonstration of debugging. If I open the console, line 47, I've made a mistake. It says name mat is not defined. And that's because I've incorrectly written the variable name. Did you notice? So before I've created a variable new mat to represent our material, but here I've only written mat. So I need to resolve this by fixing it, typing new mat. Now if I delete the object and run the script again, it runs fine. Now if I go into the rendered mode, and I should also really set the world background to black. Then we have the emissive object here, and if we take a look at the material nodes, it automatically creates a principled BSDF, we don't need that, but the emission shader has been created, the color has been set to cyan, and the strength has been set to 500. The connection has also been made between the output position 0 and the input position 0 of these two nodes. But of course we can't really see the color that much here, so let me just increase the intensity value of the bloom in Eevee, and then we can see the blue outline. So well done with this script so far. We have imported the modules, created a cube, made it the selected object, rotated it, added a subsurf modifier, increased the subdivision levels, shaded it smooth, added a displacement modifier, created a texture for that modifier, changed the texture values, specifically the noise scale, then assigned the texture to the displacement modifier, then created a new material, appended it to the object. Then we did some node stuff, basically making a reference to the material output node, creating an emissive shader node, changing the values of the emissive shader, and then connecting those two nodes together. So far, this has given you a demonstration of how to manipulate most of the major types of data inside of a blend file. But how do we take this further? Okay, this is where it gets a little bit more complicated. I imagine that some people might want to drop off of the video here, but now I'm actually going to show you how to turn this script into an actual add-on. So this is something that you'd be able to call from a blend file, and it would be able to pop up in the bottom left of the 3D view with a bunch of parameters that you could change on the fly. Okay, so inside of Blender, you can actually go to templates here in the text editor window, and then there's templates for Python and Open Shading Language or OSL scripts. This is a good way to study using Python for Blender because you can see all of these different demonstrations of code that you can study for yourself. One that we're going to make use of for turning our script into an add-on is operator simple. So if we click on this, it will add a new text file to our list of files, and it's called operatorsimple.py. Now we're not going to need everything in here. In fact, what we can do is delete this def main section. We're going to delete this class method section with def poll. Basically, all of our code that we're going to use, we're going to put inside of this area called def execute, and I'll explain this a bit more. Imagine this code as like wrapping paper or packaging for an order, something you've brought online. So if you brought something from Amazon, it gets delivered to you, but the only thing you're interested in is the actual product itself. But to get that product to you, Amazon has to package it up and apply labels and stuff, and it's all really boring, but it's essential because without that packaging, Amazon and the postal service has no idea where to put the product, or rather where to send the product. Now with making an add-on in Python for Blender, something similar applies. Inside of this def execute section, this is where our product or our code is going to go. Everything else is just wrapping paper, packaging and labels and important stuff for Blender to know, but not really for us. So whenever someone runs your add-on, it will execute everything inside of the execute section. Everything between def execute and return finished. This section of code here, called def poll, basically lets us look at the context of the blend file and see whether it's an appropriate time to run our code or not. In this case, return context.activeObject is not nothing. So basically looking to see if an object is selected before we can run the operation. We don't really need this for our situation. It's not required, you don't need it, but it's there if you want it. Plus, you always have the option of writing your own exception inside of execute here to see whether or not an object is selected, to say whether or not you will actually run the rest of your code. So there's lots of options available to you. Now in this video so far, we haven't talked about classes or defining functions. Functions are a way that you can store code and then recall them really easily. So say, for example, that we put code inside of execute here, and let's say that I wanted to do the same thing over and over and over again, but I didn't want to have to write the same code out over and over again. Then I could always type out execute and then the round brackets. And I can do it again and again. So it saves you time of writing code repeatedly. But in the case of writing add-ons for Blender, Blender looks for very specific functions, which is why execute and poll are unique, because Blender will look for them and then recall them in certain situations. At the top here, this is like the label on our packaging. This basically tells Blender where to store stuff. So if I remove tooltip, I'm actually going to name our class myOperator. So BL_ID name, you can think of this as the code address for our add-on. So object dot, I'm going to name it my_operator. So say someone wanted to call our add-on from the Python console, they would type in something like bpy.ops. Then object.myOperator. Object.myOperator. Whatever we change this to, we would have to change down here as well. And we can see in this template script that at the bottom, there's a section for a test call. So this is where we would actually test to see if the operator has successfully been registered. So I could type in my operator here. Okay, now we'll take a look at this bit. So you'll see two more special functions here, def register and def unregister. This is how we actually submit our add-on to Blender. When this script runs, Blender will reach this line and it will run bpy.utils for utilities, .register class, and then it will be our class name. So I've got to change this to my operator. And then when Blender's done with the code, perhaps when it closes or we uninstall it, it will run the unregister function for my operator. And you don't need to understand necessarily what these lines mean, but it basically means that if we're running the script standalone here inside of the editor, then it will make sure to call the register function. So when we run the script for the first time, it will actually add the operator to Blender's list of all the operators. So let's give this a try. I'm going to run the script now, Alt-P. Of course, nothing will happen. We've got no code here. But then if I go to the search function, which you can get to by pressing F3 and type in simple object operator, because that's the name we have here, then you will see it appear here in the list. If we click on it, it will do nothing. But I'm actually going to change this name to make it more consistent to my operator. Again, if I save, run the script, search my operator, it will appear there. So now we have it available in the list of operators. So now what we need to do is add the code to this execute section. So I'm going to go back to our regular text file. We can literally copy all of it, except for the import stuff, but we'll need to remember this. Go back here, paste it in, and then we've got to make sure that our indentations are correct. So I'm going to select all of this, tab once, tab twice, that's appropriate indentation. If we ran this now, we would get an error because remember, we need to import radians from math. So I'm going to copy this line, put this in here. That's fine. Then I'm going to run the script, Alt-P. Now, it actually created a new cube object again, because we have this test call at the bottom here. So I'm going to delete both, run it again just to demonstrate. There you go, created it again. So if I delete this now, go to our search menu, find my operator. If I click on this, it calls the script, all well and good. So now we've added it to Blender. So if you wanted to give this script to someone else to install as an add-on, you could just take all this code, copy it into a text file, save it as a Py file, and give that to someone else. They could then go and install it, preferences, add-ons, install, and then choose the Py file. It's that simple. However, of course, there are some caveats because there are some conventions that you should follow, especially with 2.8 and onwards, but we're not going to cover that in this video. But one of the last things I want to show you is how to get a properties window in the bottom left here of the 3D view so we can adjust the values and actually watch our mesh change as we've created it. But before we do that, there's one more thing I want to add. If you want to let your operation be compatible with Blender's undo system, you need to register it with the undo system. So underneath BL label, we can do BL_options equals, and then we're using the curly brackets instead of the round brackets. The first string is register in capitals. The second string is undo in capitals. So I can run this again. There we go, no errors, fine. Now, as for creating the properties here in the bottom left, this is where things get slightly more advanced again. So we're taking another step up in complexity. Just like we've created this packaging, these labels for our add-on code, for the variables that we want to modify live, we also need to create some packaging for them, so to speak. So inside of our class, we need to create properties. And properties are essentially our variables, but they're just glorified variables, really. We can give them like names and descriptions and stuff as well, basically metadata to go along with the actual value. To do this, I will need to import one more thing. I will need to type in from bpy.props, meaning properties, import, and then the asterisk, which means import everything. Because there are many different types of properties representing different data types. Integers, strings, booleans, enumerations, stuff like that. If you've never done coding before, a lot of those words won't mean anything to you. That's because Python, so far, has been a loosely typed language in terms of data types. Basically, whenever we create a new variable, like a modifier or a texture, we don't need to tell Python what type that variable is going to be, because as soon as we assign it, Python goes, oh, okay, this is a texture, or this is a modifier, and stuff like that. It automatically figures it out for you. When it comes to properties, this is not the case. We need to say specifically what type you want the variable to be, so Blender knows how to present it. For example, if it's an integer, it needs to know to create this kind of box for it, where we can scrub up and down. Or if it's a boolean, it needs to know to create a tick box for us. So that's why it's important for Blender to know. So I'm going to type a comment here, create properties. Now, because in our script, we're modifying the noise scale of the texture, we're going to type in noise scale, and then I need to do a colon, float property. Now, a float, otherwise known as a floating point value, is basically a decimal value, like the threshold here, 2.0. It's got a point there, and that point can float between the numbers. Then I'm going to open a round bracket, leave a couple of lines, closed a round bracket, and then type in name equals noise scale, description equals the scale of the noise. You can write whatever you like. And also notice I'm putting commas after each of these values. Default equals, and then you put the default value, I'm going to put it at 1.0, that seems appropriate. Min equals 0.0, and max equals 2.0. So the minimum value, for example, if we were playing around with this threshold value, would be 0, and the maximum in the threshold value here is 10. So we can set minimum and maximum values if we like. Okay, so basically we've created a property called noise scale, and we've given Blender a bunch of contextual information, so it now knows how to present that property in an extra window. So now we need to replace in our code the hard-coded noise scale value here with the property we've created. And to do this, all we need to do is type in, instead of 2.0, self.noise scale. Basically, whenever you want to access a property you've created inside of the class, you need to type in self. And what that means is it looks at itself, naturally, and then finds noise_scale. So I can save, run the script, and then it creates this cube. But if we run the script from here, it doesn't come up with the properties window. So let me delete it, search my operator, click, and then you'll see here in the bottom left, my operator, I can click this to expand it, then it says noise scale, and then it's got a box which we can scrub, relevant for a floating point value. And if we hover over it, a tooltip appears and you can see it's got noise scale and our description we've written in the scale of the noise. So this is how you can create properties which you can change as you create an object using your add-on. So yeah. So this has been your crash course into Python for Blender with me, Curtis Holt. Hopefully this has taught you something. We've covered quite a lot of stuff, especially for someone who's new to Python, different ways of accessing the different types of data within blend files. And hopefully this has given you enough information that you can actually go on ahead and write your own scripts and add-ons and start experimenting. If you want to download the final copy of this file, then I will put a link to it in the description, so feel free to give that a download. And also if you want to support my work, then feel free to leave a tip on the package. I appreciate all of the support from you generous, lovely people. Alright, so now we've come to the end of the video. We're going to take a minute to talk about the sponsor for this video, which is Sketchfab. You may already know Sketchfab for providing the best 3D model viewer for the web, but you might not know that they actually have an online store for buying and selling 3D models. You can use the built-in model inspector to preview the geometry of the mesh, along with all the textures so you know exactly what you're getting. There's a wide range of content available and a good number of dedicated artists providing high-quality content. If you're interested in maybe selling your own models on the store, then you can also consider applying to become a seller. Sketchfab has been well integrated with the Blender community for a long time and continues to provide a valuable service for all kinds of artists. So thanks for sponsoring this video, Sketchfab, and thanks to the rest of you for watching. Make sure to follow me on all the appropriate platforms. You can also join our Discord server with the link in the description. So thanks for watching, have a great day, and I'll see you next time. Now if I do the object,